Talking about text mining. And now let's look at the idea of what we mean by information extraction. So basically, this is the process of extracting a specific. And when we say specific, basically what I imply is that you already predetermined what kind of information you want to collect. So it's pre-specified, predetermined information from textual sources. A simple example is given here where you're looking at an email and trying to extract from that if there is any meeting that is being planned and what time is the meeting, what day is the meeting, where is the meeting, things like that. All right. So that will be a neat example of information extraction, and it's already there in most of the systems that you use. They already have something like this built in. Here is a slightly different example of information extraction example, and this is more useful from a business perspective. So in this case, in the left hand box, there is a news story that has come out from a wire service. So basically it talks about SAP acquires bits of our compliance capability. All right. And now if you have a piece of software that performs information extraction, so that piece of software is going to extract from this story certain relevant, useful information that has been pre-specified what kind of information we want to extract. So for example, the system will extract, are there any companies mentioned in this story? And if there are some companies mentioned in the story, what are their names? All right. What kind of industry or the terms defining those companies are involved? So in this case, risk management software or something like that. All right. And also what kind of product, any name of the person involved, and things of that nature. All right. So basically what happens is that if you have a system like that, that system can look at all the stories as they come in. And from those stories, it can extract this kind of information and put it in a database where you have then, you can make use of this information later on, either to answer queries or for any other purpose that you might have. So if you look at why we need to do information extraction, the point is that we want to gather detailed structured data from text, and this process will help us in automation of tasks such as smart content classification, integrated search, management, and delivery. So basically, you can say you are talking of text analytics, data-driven activities such as mining for patterns and trends, uncovering hidden relationships, etc., that might be present in these stories. All right. And below here, I show you a couple of applications where information extraction is used very heavily. Obviously, it is used for business intelligence so that analysts are able to gather structured information from multiple sources. Financial investigation for discovery and hidden relationships. Scientific research, you could apply this to keep track of how the field is moving and what are the new papers coming, what are the new discoveries taking place, and what is the trend and all that. Again, automatically this can be done. Media monitoring, one can keep track of all the stories that are being published in the media, and especially if you are a company that is interested in, for example, maintaining your, you want to keep track of how you are being perceived, how you are being represented, or how you are being showcased in the media, then obviously you want to keep track of all the stories where your company's name or anybody associated with your company is appearing and in what context they are appearing, and whether those stories are positive or negative for your company and things like that. All right. Healthcare records management, obviously, one can use this for structuring and summarizing patient records. Pharma research, again, basically, when people publish reports about adverse drug trials and things like that, again, through information extraction, one can basically extract the names of the drugs and the related adverse effects and things like that. So there are number of use cases, number of applications for this particular process. So let's look at what are the steps that are involved in information extraction. Obviously, you start with a raw piece of text, all right? So a news story or whatever it is, all right? So basically, it is a string of characters, all right? So first thing you do is you break that text into individual sentences. So you need to figure out where a sentence begins and where a sentence ends, all right? And once you have separated different sentences in the story, then you perform tokenization. That is, isolate each word in the sentence. Remember, some of these steps we did when we talked about text representation in the form of a vector. We were basically doing many of these things, all right? Next is, and this is something we did not do earlier, that is part of speech tagging. That is, each word that has been, or each token that has been separated out, now you may want to classify that token from a grammatical point of view, whether that token is a noun or is a verb or adjective and whatever it is. All right. So that is what we call as part of a speech tag. And what that does is that allows us to basically, it helps us in doing downstream process. So once part of speech tagging has been done, we can perform what we call as entity detection. That is, what are the nouns that are present in this story? What are the names? What are the places? What are the numbers that are being mentioned in this story? All right. Once you have done that, then what one can do is one can try to figure out, are there some relationships between these entities? And what are those relationships that are present in those entities? All right. So these are all steps that are involved in an information extraction process. So part of speech tagging, as I mentioned, basically it will label different tokens as noun, verb, adjective, preposition, etc. All right. Now one can try to figure out how that is to be done. All right. So part of speech tagging, generally there are two broad approaches that people follow. One is what you can call as a rule-based approach, and second one is a statistical approach. In the rule-based approach, basically we make use of language rules to improve the accuracy of tagging. The limitation of this approach is that you need large annotated data which require expert linguistic knowledge, labor, and cost to come out with those rules. All right. Another approach is to make use of machine learning itself. Basically, you can look at part of speech tagging as a problem of classification. Given a word, is it a noun or is it a verb or is it an adjective and so on and so forth. So basically, you want to perform classification. So obviously, the approach will be that you will have to figure out a set of features. Typically, what will be done is that the word itself will not be taken in isolation, but the word will be looked at in the context in which it appears. And that context will define some kind of feature vector for that word. And obviously, you would collect a lot of data for training. And then you use that data to build a classifier model. And then that model is used to perform part of speech tagging later on for any new things that show up for your system. All right. So basically, you are training a classifier and then you're using that to tag parts of speech. The next step, if you look at the diagram I showed you earlier, once you have done the part of speech tagging, what you want to do is you want to perform named entity recognition, or NER. So the task here is to recognize those tokens that represent persons, organizations, locations, and geopolitical entities. Again, one can have two broad approaches. One is a rule-based approach. And the rule-based approach uses regular expressions. And basically, one has to hand code rules. And of course, the rules are domain dependent. Obviously, it's an expensive approach and changes over time in terms of the uses and vocabulary, then can create issues for this particular approach. The other approach is, again, follow the machine learning approach, collect a lot of training data, figure out some features, and then build some classifiers. All right. Everybody is familiar with here, the point I mentioned here, cheap annotation, mechanical Turk. Everybody is familiar with what we mean by that? Okay, now they're asking. How about anybody else? No? Okay. Nowadays, everybody is doing AI, all right? And for AI, basically what they're doing is building classifiers. That's all. They call it AI, but basically it's all machine learning mostly. All right. Now, to do that, obviously, you need a lot of training data with labels for supervised learning. And most of the work is supervised learning. All right. So let's take a case you want to build a system that can recognize objects in pictures. Okay. Now there are thousands of different objects. And to train a system that can handle so many different types of objects, you obviously need millions and millions of images for training. That means those millions and millions of images must be hand-coded by people to say, all right, this image represents a Mercedes car, this image represents two people talking with each other and things like that. All right? So obviously what companies are doing is that they will put this requirement that we want people to annotate this data, and we are going to pay you 1/10 of a penny per picture. There are people who have nothing else. They can basically look at these images and kind of tag them. All right. And of course, depending upon the domain, the price might be a penny or 1/10 of a penny, or it could be even more. Yes, you are doing it manually. All right. Only thing is you are fanning it out all over the globe. In USA, nobody is going to do it for a penny. But there are places where penny translates into a much higher value. All right. And people will do it as long as they have internet access. And nowadays, internet access is everywhere. All right. So basically, and obviously, what you need to do is you need to make sure that this annotation is correct. So typically, for every image, or for every object that needs to be, or every example that needs to be annotated, you will get 5 or 7 or even higher number of annotations. And then you can match them and say, all right, is everybody saying that this car is a Mercedes car, or somebody is saying something different? So that way you can ensure that there are good matches in terms of different people annotating the same object, and you have a matching result from different person. All right. Why it is called mechanical Turk is, I think, about 100 years ago, there was a person who was trying to fool people by some trick, and that trick was called mechanical Turk. So that's how that name comes in.
This is not, this is logical, right? Cheating in this, sending it to then collecting.
Pardon?
Sending across people and collecting, this is straightforward approach, right?
Yeah, this is purely logical. There are companies that actually do it. So you can go to them and say, all right, I have this project, I need annotated data, and they will basically do it. So they'll, and in many cases, what they do is they will create a game.
Identify the circles, identify the patterns.
Yeah, so they'll create a game. Yeah, people generally are not going to come and do this. So they'll kind of make it little interesting, create a game where while you are playing the game, you are performing the annotation task. And in many cases, you get paid also to do that. So basically, it's a kind of way of getting annotation done. All right. Okay, we clicked on that, and what happened? Okay. All right. So that's what we were talking about here. All right. And of course, in order to do this, you definitely need to keep context involved. Otherwise, in isolation, a word can be, given different meanings, different interpretations. All right. So context is important. All right. So that is what we were talking about, named entity recognition. And let's look at some example. So here is an example of rule-based named entity recognition. So the text is shown there. Hillary Clinton, tore into Donald Trump, whatever it is. All right. And then if you look here, we are basically making use of a regular expression tool to define the rule, and that is being defined here. And that, as per that rule, then we are able to clear out these names, Hillary Clinton, or these terms or tokens, you can say Hillary Clinton, Donald Trump, this, that, because these are all starting with a capital letter. So you are defining the rule that, okay, pick out those tokens that start with a capital letter, because if you're talking of names of persons or places, that is how it should be. All right.
The line, the graph code.
Yeah.
Is that the one that mentions?
That is the rule, right? That, okay. That's basically saying look for A to Z as the uppercase to identify.
What if, like, by typo, Hillary, the H is the L is also capital, then what?
If there is a lowercase,
No, uppercase in between the, like, for example, Donald Trump, O is capital O. Is that?
well, there's always a chance of something not properly inputted or something with some mistake. Sometimes you may not, you'll get some error. Okay.
For example, somebody say N-O capital, both N will be capital and O will be capital to give some effect. In that case, this will, what to do?
Well, basically it will pick up, it will follow the rule because the rule has been defined. So obviously in certain situations, the rule may pick something which is not correct. This happens with all the rules. Yeah, so it's nothing surprising here that it will happen. Okay. Now, obviously, a rule-based approach is a little complicated in the sense that you need lots of rules, and if you make any mistake in defining those rules, you end up with incorrect results and things change. So obviously, it's not, it's good for small applications, but for large scale applications, it really doesn't work that well. All right. So typically what people do is they have again built machine learning systems using a lot of annotated data. And those systems then once you give an input, they will basically pick the things as per you want. So here is a system. I think it's known as GAT. This is an open source old system. And essentially what we have done here is, if you look at, there is a text, the New England Patriots have identified whatever it is, all right? So that is the text that has been inputted. And what the system is supposed to do is to identify all the entities that are mentioned here. So it does pick up New England Patriots. It does pick up Kansas City Chiefs. It also picks up the name of the receiver, Tyreek Hill, etc., Gillette Stadium. Okay, so basically that is what it is doing. All right. Now again, I think this system, the point I wanted to mention was that this actually system was built in UK. So originally it was meant for British English, but then later on they have added variations so that it can handle also American English. And think of, you need such systems in all the languages, because if you are, especially if you are somebody who is working in the area of intelligence for a government, obviously not only you need to look at what's happening in USA, but you need to look at all the reports that come out of China or Poland or Japan or any other country. That means you need to have such systems being able to work in multiple languages. All right. So here is a system that actually can work in multiple languages. It's called spacy for NLP in Python. It's an open source library. And some of the steps that I mentioned so far, all of them can be done very easily using this library. And this library has many languages. So basically you can use this library not only for English, but for a variety of different languages. All right. There is another toolkit for natural language processing that is known as NTLK. NTLK is an older toolkit for natural language processing. Spacy is relatively newer. There is another one called FLAIR, F-L-A-I-R, and that is also an open source library for natural language processing. Now, a couple of other advantages of spacy and some similar libraries is that these come with built-in word vectors. remember last time we talked about that in order to get really good results, one needs to represent each word as a vector. And I mentioned one or two different ways of how one can do it. All right. So this library, as well as a couple of other open source places, do come with built-in word vectors for different terms. That means you can use this library and then pick up the word vectors for different words that you're interested in and use them for your work. All right, so that's a big advantage. And also, as I mentioned, it comes with built-in language models for many languages. So you can use it for multiple languages. All right. Let me show you a couple of examples of how you will be using this or how one can use this. All right. So if you want to use it, obviously you have to install a spacy on your machine. All right. So usual pip install or whatever you want to use, you install that. All right. Now, when you install, there are two kinds of language models you can install. And once you install and when you want to use it, you can load the small language model or you can load the large language model. Obviously, large language model has many more features compared to the small language model. And for some applications, a small model might be good enough, but for certain applications, you do need a large language model. All right. So basically, if you look at here, from spacy.lang.en, so en is indicating English. We are importing language model for English. All right. So basically, once we load English, basically we are loading tokenizer, tagger, parser, named entity recognizer, and word vector. So all those things are actually loaded. All right. Now you can look at the text that is shown here. The United States is ending the rotational deployment of, so many Marines to Norway and all that. All right. So we can basically ask spacy to look at this text and generate the list of tokens that are present in this text. All right. So basically that is what is going on there. And once it has identified the tokens, it can create a list and print them out. All right. So basically you can see that we have we are printing all the tokens. All right. This we could have done also in sklearn library when we were doing TF-ID, vector-ID. All right. So it's pretty much similar here. Now let's look at how you can do the named entity recognition in this space. All right. So in this case, spacy has a nice feature. Basically, it will show in color code different entities that it recognizes. So you look at the text, it says the United States is ending the same text that we saw in the previous slide. All right. So it has highlighted the United States. All right. And it is saying it is GPE, which means geopolitical entity. All right. That's the term they are using. All right. And some 700, you can see that it is saying cardinal. That means this token refers to some numeric information. All right. Again, US is GPE. Marines is NORP. This is some kind of organization that they are representing. All right. Norway, again, GPE. And Pentagon is an organization. The US Navy is an organization. Europe is a location. All right. So basically what spacy does is they already built in all this. So you can directly use this to do the named entity recognition.
Not this nationalities, organizations, or religious groups.
Which one?
Not this nationalities or religious or political groups.
Yeah. Yeah. Okay. So basically, that's what you can do. All right. So again, you don't have to worry about it. But sometimes what happens is that what you want to do is you have a specific application, because this system has been trained for general domain. But if you are working, let us say, in the biomedical domain, where the papers or the text will be talking about the different diseases, different drugs, and different things. All right. So what one has to do is one has to then create, either from scratch, a separate named entity recognition system for such applications, or sometimes what people do is they take these systems and kind of retrain them with additional information, and then that's how they are used. All right. Let's look at the example of part of speech tagging. Again, in the spacy, you can do that. So if you look at a statement or the text, Tesla reports 5th consecutive quarter of profits and so on. So basically at the bottom, it has found out, Tesla is a proper noun, reports is a verb, 5th is adjective, and so on. So again, this can be done. All right. Here is an example of word vectors. I mentioned last time and that these representations involve 300 or even more dimensions to represent each single word. All right. So the spacy library comes with built-in pre-trained word vectors. And if you want to use these word vectors, you will need to load the large language model, because large language model has 300 dimensional vectors. I think the small language model has 50 dimensional vectors. All right. So here is a representation in 300 dimensions for a word called pet. So what we are doing is pet dot vector. If you input that to spacy, basically you're telling spacy, give me the vector representation for word pet. All right. So basically you get these 300 numbers. So this is a vector representation for term or word pet. All right. So now let's use this idea to do the similarity. All right. So what we can do is we can get the vector representation for cat. We get a vector representation for dog. And if you want to get the similarity between cat and dog, so cat dot similarity dog, basically we get 0.80. All right, that means there is a very high similarity, although the two are not the same object. But remember, last time when we were talking about similarity, that is, if you're talking of pets, yeah, they are similar. If you're talking of people in the same context or objects in the same context, then there is a similarity. All right. So, and also if you want to calculate the similarity with pet, so pet dot similarity cat, again, the number is 0.75. So again, although we are using a different word here, but still pretty high similarity. And same way, pet similarity with dog is 0.80. All right. So basically,
so cat similarity with dog similarity with cat will be the same number.
yes. Yeah, because basically you're looking at two vectors and calculating their dot product. So it doesn't matter whether you put one vector first and second one later. It's the same. All right. So essentially, this idea of word vectors or word embedding, as it is called, gives you a better handle on capturing the meanings of different words. So if you're looking at any application where you need to capture some semantics, some meanings of what is being talked about, then it is better to use word embedding or vector representation for words, rather than using only the TF-IDF representation. Yes, please.
Does that indicate that it's stronger recognizing dog? The higher value?
But it basically, I think, pet and dog little stronger,
Like
which
it's better trained on dog than cat.
yeah, and I think basically, that could be depending upon, their data that they use. Or in general, also, I think when you talk of the pet, generally, the dog is what comes first in the mind, not the cat. All right, so that's, again, it's captured. Okay, yes, please.
Does that library have a function to go the other way? So given a vector, find the closest word.
Given the vector, find the closest word. That's a good question. And it's possible to do it. Basically, all you have to do is to find out, calculate the given vectors, dot product. It's a nearest neighbor classification.
So you have to dial every other.
Yes, right. So typically what people will do, if you want to do it, you will actually take your entire data and first do the clustering. So you cluster it into, let's say, 100 clusters. Then you take your vector and calculate its similarity with the centers of these 100 clusters. So then you don't have to, okay. So that's how you will do it. It's doable. Okay. So let's come to the next thing, which is, a lot of people like this. So how do we now, based on whatever we have done, how do we perform sentiment analysis? In the sense that given a news story or a piece of text, let's say somebody sent out a tweet about the midterm election results, all right? Whether the person is, supportive, happy with the results or unhappy with the results, all right? How do we figure that out based on that tweet? All right? So that is what you can call as an, opinion extraction, opinion mining, sentiment mining, subjectivity analysis, etc., etc. So basically, those are the different terms with some minor variation. They refer to the same thing. And you can see that doing this is pretty important for a number of applications. So doing sentiment analysis helps companies, entities to respond in a timely manner. For example, if you put out a tweet criticizing some airline, let us say, and that there are a couple of other tweets that come out and criticizing, and if the airline is keeping a good tab on the social media, you will immediately see a response coming from them saying, making some, correction or whatever it is also. And also one can use this to do predictions for elections, stock market and things like that, because how is the sentiment? What are people saying about different issues? What is their sentiment? And you can use that to kind of guess what is likely to happen. All right.
So stock market can be predictions and start like popularity.
Well, if you keep hearing in the news reports or in the tweets or on the TV channel some negative reports about a particular stock, then basically chances are that that stock is going to go down. So these are not for long-term projections. These are basically, there are companies that do this. Overnight, they will collect every piece of story or tweet that has been said about, let's say, Apple. And they will go over that data and they will extract some number, which is indicating, let us say, sentiment or polarity or whatever it is. And that number will guide then their action next day. So not for long term, but for short term.
Most of the trading on the stock market's automated today, so that's a machine
Oh yeah,
getting the sentiment of another.
yeah. There are, in fact, there are a number of papers people have published showing that by incorporating this additional information, because this is an extra information. You already have all those stock market indicators that you're using. On top of that, you have some of this, and it can improve your performance.
So the better data analyst could do better than stuff.
Sure, absolutely. All right. By the way, stock market or some companies on the stock market are very big employers of all the data scientists. Okay, so let's look at how one can approach sentiment analysis. Let's start with a very simple approach. Now, one can create a list of words, and in that list you can say, all right, these words are positive words and these words are negative words. All right? Instead of creating one, in fact, people have already created. So there are lists of words that tell you, okay, the words in this list are positive. They even tell you how much positive they are. All right. So how much, you can even assign them a weight of how positive they are and how negative they are. So assume that you have a list of positive and negative words. All right. So all you have to do is, when you get a piece of text that you want to classify in terms of sentiment, basically throw out these top words. All right. See whether the words from the list that you have are present there or not. So count how many of them are present, which one are the present, what are their respective positive, negative weights, and it gives you finally a number. So that number tells you whether it's positive or negative. All right, it's a very simple approach. Obviously, this works to some extent, but not a great approach. So again, for real work, what people do is you collect a lot of data, get annotation done, labeling done, positive, negative, whatever it is, and then train a classifier and then use that classifier. And what people have found is that if you train the classifier, for example, using vector representation of TF, IDF, you get, with let us say, naive Bayesian, for a typical sentiment analysis, you possibly will get somewhere around 75, 78, 80% accuracy. If you use the embedded word model, you will find that the accuracy can be improved by about 10, 12 points. So basically, that's how one can actually do that. All right. So here is an example of a very simple sentiment analyzer, which you can implement on an Excel. You don't need anything else. So basically, you take Excel. Excel has a feature, text to column. So basically, if you put your entire text in, let us say, one cell A1, and then you issue a command, text to column, what Excel will do is it will isolate each word and put them in different columns. So basically, it is doing what we saw earlier, tokenization, and it is putting every word in a different cell. All right. So once you have words in different cells, you can actually check whether the words from your list are there or not, and give them the corresponding weights and do the job. So if you look at this example here, so in the first row, the course was in great shape and so on and so forth. All right. So that is after text to column conversion. And then below, in the second row, what you are seeing below every cell is a number. So basically, for the first 4 words, the number is 0 because those words really are neither positive nor negative. All right. But then you see the word great, that's a positive word. So basically, from that list that we are using, great has a weight of 3. So we get a weight of 3 there. And then, everything else is 0. And then you have fairways are in bad condition. So basically another word, but this one is negative. So basically, again, it has a weight of -3. So -3, and then if you followed it down, there is a word called disappointing, which is kind of negative connotation. So it has a weight of -2 and so on. So based on this, basically we'll say that overall, the sentiment expressed in this particular sentence or this particular piece of text is negative. Because you got the +3, -3, and -2. So overall score is negative, that means it's a negative sentiment. So it's a very simple scheme. You can implement it in 5 minutes and can be done. But again, this is not going to give you great results, but it will give you reasonably acceptable result. So if you want, you need to, do a classification model by training either a naive Bayesian classifier or logistic regression classifier with either TF-IDF or better with word embeddings to get improved results. All right. If you want to look at this particular list, there is a link there mentioned that you can look at the list of positive and negative words. Another point I wanted to mention before we wrap up this topic is called topic modeling and document clustering. I just wanted to differentiate between the two. So when you have a huge collection of documents, you need a method to organize the collection. All right. And basically, it turns out that you can do so either by topic modeling or by clustering. So those are two options you have. In topic modeling, a topic is defined by a cluster of words, with each word in the cluster having a probability of occurrence for the given topic. And different topics have their respective clusters of words along with corresponding probabilities. Different topics may share some words, and a document can have more than one topic associated with it. In clustering, the idea is to group documents into different groups based on some similarity measure. The result of clustering is a list of clusters with every document showing up in one of the clusters. All right. So basically, in one case, you are working with words to kind of define whether a document falls in a particular topic or not. And in another approach, you are looking at the entire document as a whole and then trying to do some clustering. So if you want to see some more details, basically, again, you can look at these two links that I provided here, where you can read a little bit of difference between the two. But at a very rough level, there isn't a whole lot of difference between the two. Okay. What you can do is, once you've done the clustering, you can figure out what are the most common words occurring in that cluster, and you can create what is known as a word cloud, and you can actually give some weights to different words in the word cloud, which will be very similar to doing topic modeling. So when you try to do some of the text analysis, you will come across people doing word cloud, and you may also want to do the word cloud. So that gives you a nice visual picture of what's in a particular collection. All right. So to summarize text mining, there are numerous applications of text mining, and we have looked at some of them. And heavy use of NLP for some of the text mining tasks is needed. And nowadays, a lot of work in this area is being done using deep learning models. So the models so what we have discussed so far is pretty basic. But if you look into the current literature, what they are talking is large language models. That is, these models have been trained using hundreds of billions of documents. And these models have parameters close to billions. And what you can do with these models is that you can actually generate stories which will appear to be as if they have been written by a human being. So a lot of fake news can be generated using these models. And currently that's really, a lot of discussion is going on about that. How do you, stop these models for being used in that purpose? But there doesn't seem to be any way to stop it. All right. So that's, if you take the NLP course or if you do deep learning little bit next semester, I touch upon it, but obviously in the NLP course, I'm assuming that they will go deep into that. But again, I really don't know. Okay, so we will stop here.